Yes, today I want us to perform an independent sample t-test. And in this t-test, I'm having the same data set I had last time. And the data set has three variables. Number one variable is the protocol type. The variable protocol type has two categories of data. And the two categories, one category is labeled 1 and the other category is labeled 2. As I can scroll down here for you to see, you can see the other category is here labeled 2, and the other category you already saw above that it is labeled 1, as you can see here again. And the other variable is queue time, and the fourth variable is service time. Now, I want us to perform our independent samples t-test. It is also known as two samples t-test. And this t-test is normally performed when you are having one continuous or numerical data and another categorical data. This is performed, and also remember that the categorical variable data should be having two categories. So when you have it that way, you can be able to conduct an independent samples t-test. And this test is normally applied also when you are having the same a data or maybe a variable with values that have been subdivided into two categories. And among these two categories is where you do your comparison to see whether this one category is the same as the other category or not. I mean, are there differences between the two categories or are they the same? Now, when you are performing this independent samples t-test on your SPSS, I told you last time that whenever you are performing any t-test or any comparison for means, because I mean, a t-test will always be comparing means. So you will always go to analyze on your SPSS environment, go to compare means, and then you look for independent samples t-tests, this one, and you can go ahead with your test. Now you can see a pop-up window here. And in this window, on one side, you are having your variables. And on the other side, you can see your, the boxes in which you can input your variables depending on the dependent and the independent variables. Now, here on the right, you're going to, under the test variable, you must have to pick your dependent variable. And for my case, it is queue time. I pick it and add it there. Again, on on the grouping variable here, you're going to pick your categorical variable, which is protocol type here, for my case. And again, you must have to define your groups. And when you are defining your groups, you will basically be adding the values of the two groups you are having. Group 1 For my case, I have the value 1. For group 2, I have the value 2. And I click continue. Now I go to options. Under options, I told you that you will always find the confidence interval percentage. And this confidence interval, you will normally like to leave it as default unless instructed otherwise. So the default is 95% confidence interval, and you click continue. Now you can also click OK to go ahead and perform your test. Now I need to stop sharing this screen and move to the results screen. As you can see, I need to share my results screen, which is here. A moment, please, and you can see my screen. It is just right here. The test we have conducted, it's generally, the SPSS generally calls it t-test. And as you can see, the first result, the first results here are the group statistics, and the group statistics will always give you the total number of observations for each of your samples, for each of your categories. It will always give you the mean as well, the mean for each category. It will always give you the standard deviations, or SD, for each category, and the standard error means. Now, while interpreting this, or just by general observation, you can see that we are having 853 observations for our category 1 and 821 observations for our category 2. Category 2 of the Q time. Again, we are having a mean of 147.56 seconds. That is the Q time, a Q time of 100, a mean Q time of 147.56 seconds, with a standard deviation of 136.9. Again, we are having, for the second category, we are having a mean Q time of 148.30 seconds, with a standard deviation of 139.15 seconds. You can leave the standard error mean that way. Again, you can see now our main results for the independent samples t-test. And here you should always start with Levin's test for equality of variances when you are interpreting the main results. Now, the Levin's test for equality of variances has an F statistic, and with its significance value, or the p-value. Now I'll teach you how to interpret this one. Whenever you are having, or the main purpose of this F statistic in the independent samples t-test is always to, of course, it is always to guide you on whether the equal variances of the samples are assumed, or the equal variances of the samples are not assumed. So when we have equality of samples, when we have equality of sample variances for Q time, or when we don't have equality of sample variances for Q time. Now, the rule is normally very easy here, that when you are having a significant p-value of the F statistic here, you must always reject the null hypothesis for equality of mean variances. I mean, for equality of sample variances. And the null hypothesis is always that there is no differences in sample variances, or the sample variances are equal. And when this p-value is not significant, you can always fail to reject the null hypothesis and conclude that the variances are equal. So in this case, because our p-value for the F statistic is not significant, it is greater than 0.05, we are going to say that we do not reject the null hypothesis, and therefore we assume that we have equal variances of our two categories, of our two samples of Q time. Now, when we assume equal variances, it means that when we come to the T statistic, we are going to use these values above here, the values above, not the values lower. I hope there you get me right. So when because our p-value is not significant, we assume that we have equal variances, and because we have equal variances, we are going to use the equal variances row to interpret or to report our test results. And now, as you can see, we are having a T statistic of negative 0.11 with a p-value of 0.91. Now, this significance or p-value is not statistically significant. And of course, you can see the degrees of freedom. You can see the degrees of freedom for our test. It is 1,672. Now, because the p-value here is not significant, since it is greater than 0.05, then we still have not to reject the null hypothesis of equality of means. We still don't have, or we still must not, we should not reject the null hypothesis, and we should conclude that we have equal means. So the means for the two samples of our Q time is the same. Yes, I repeat again. I repeat. The T statistic is negative 0.11 with the degrees of freedom as 1,672 and a p-value of 0.91. And this p-value is greater than 0.05, our standard significance level, or the significance level at 95% confidence interval. And for that reason, we are concluding that we have equal means for our two samples of weighting of Q time here. Yes, we have equal means. So with that being said, I say thank you.